We are going to get started in 1 minute, so if everyone could come in and move in and have a seat, we'll start reporting out from the discussion tables. All right, welcome back, everyone. We are going to go ahead and get started reporting out with our tables. I think all of our reporters are sitting right up front here. The format is going to be that we have 2.5 minutes for each speaker, and we'll be moving people along. We are going to throw a little bit of a wrench in it. We are going to start reporting out at table number 7 instead of table number 1 and move up from there. So thank you.
So our table had a very lively conversation. So starting with challenges of RDMI, standard at this time is that traditionally there is not IT support specifically for research data. Each research group owns their own solutions and infrastructure with no standards or best practices. Also, repositories cannot be data dumps. We need data curation. If you can't find it, you basically don't have it. Moving on to institutional challenges. Primarily, our discussion was, it's not really a focus. Research data management is not a focus within the institutions. It's also very difficult to determine if it should be a more central or democratic utility. We talked about utility here earlier. And then moving on to, are these challenges impacting, how the challenges are impacting research and discovery? Dramatic impacts. Schools that are more visionary, they have more funding, developing more data service tools, they're far ahead of other institutions. And even those institutions that have computing centers aren't necessarily dealing with comprehensive data management issues. Researchers, they are impacted every day. They try to discover data, they try to submit their own data, and there just aren't standard guidelines for how to do that.
We also had a lively discussion. The challenges that we face really fall along 4 specific lines. Intellectual property, I spoke a little bit about that in sort of following the first conversation, or the keynote speaker. A really strong challenge that all the institutions feel like they face is that of governance, is figuring out how to actually implement a solution that's going to have the greatest impact for data on their campuses. The third big challenge is sort of fear of uncertainty and urban legends. And I love the urban legend notions because we often sort of create policies around data storage for a very small minority of users, and those often are sort of under the urban legend sort of area. And then the last is security risk and compliance, and the disconnect often between the various aspects of those challenges. As far as what our institutions are doing about this, it seemed like the predominant approach was that there wasn't a consistent sort of top-down effort to get people together. There were a few institutions at our table who have recently sort of embarked on those efforts to actually try to get a better handle of these and bring providers together. And then there were some cases where there was sort of a mixed approach, sort of a grassroots approach, as well as some effort from the top down. The impact that it has on science is we started off with sort of the trite answer, but realized it's really, really important, and that is it slows down science in the best case, and it makes science impossible, unfortunately, in many cases. And you've all seen that, you've heard that. It seems trite, but it is true. We face this on our campuses, and we gave numerous examples in the notes that we have. Thank you.
I was told not to repeat anything, so I won't repeat that we had a lively discussion at our table either. I come from this from an engineering perspective, IT world, not from an academic world, but I deal quite a bit with it with ICPSR. Some of the three major areas we talked about were the RDMI as a research workflow, because part of the challenges with research is that they do their stuff really well, but then all of a sudden it falls into this vast black hole of what happens to it next. Really not their concern, they're done with it, but there's a vast interest in that data. And as the first speaker said, if you can't find it, it doesn't exist. It didn't happen, it never can be found. The other side is with sensitive data, being able to share open access is a great mantra moving forward, but open access with sensitive data is a contradiction in terms, and we need to be able to find a way to share that data, but also do it through the sensitive process of making sure the data is shared. We have some projects we're working on at ICPSR with smart multi-party computing for sensitive data as well. Those are some of the things that we're doing to attack these type of challenges. And then just the consistency of data governance, which the previous speaker had mentioned. The priorities are different among the various institutions, but more importantly, among the various organizations within the institution. How important is the data governance, and what does it mean to the researcher? What does it mean to the archivist, the librarian, the IT world, and things like that, and getting some type of structure around that. One of the suggestions with my Big Ten consortium over there at the table, as well as George Washington University and American University, is that we need to be able to have these type of workshops and some of these very topics we're talking about today individually and bring that back to the RDMI maybe at a later time. So thank you.
I'd like to add, although you were representing a table worth of views, do you mind also introducing yourselves before you speak, just because it's nice to put the name with the face?
Well, I'm Jenny Thorson. I'm from the University of Nebraska. I'm going to be stating similar things to the other ones, but in a slightly different way, so I feel like that's okay. Our table discussion largely revolved around two pretty related topics, collaboration and clarity. In terms of collaboration, we felt that progress is very slow compared to the increased complexity of data and the data management expectations and needs of researchers, and haven't really coalesced on our campuses nationally in a way that makes sense yet. Progress is happening, but it's very incremental. And in a slightly different view, we talk about collaboration in terms of who's going to be leading it. Again, whether it's at the campus level, where the leadership falls, or nationally, who's leading things like standards, for example. And very importantly, similarly to leadership, but slightly different potentially, is who's going to pay for it. Secondly, we talked about things related to clarity, and previous people have already talked about things like workflows and guidelines. So being able to support our PIs throughout the process, throughout their research, through clear processes and workflows, having standards that are available for them, and having stronger, more consistent guidelines for the expectations related to data management at the community level, acknowledging that there is a challenge of having consistency when disciplines and institutions and research groups can be very vastly different. Thank you.
What table number were you? can take 3 minutes now. I'm Raj Bose from Columbia University, Table 11. So the major challenge is the fact that there's rapid change with three things: technology, funding agency requirements, and within research domains. And all that rapid change is happening with lack of clear roadmaps and institutional policies. Also, an interesting point about proprietary data formats from some scientific instruments is creating difficulties. Addressing the challenges, well, we noted that there are some examples of successful data management infrastructure from domains, Dryad, GenBank, Protein Data Bank, iDigBio, IRIS, the seismic data. Some of those were noted as potentially successful, not that they have solved all the problems of sustainability, but there are concerns that institutions cannot handle this alone to create more successful examples, and we might need national level support. So again, working with the funding agencies, perhaps. Some institutions are creating many groups to handle data management in various parts of the institutions, which is one way of addressing it, maybe not the best way. And then the impact is that there is a greater awareness of data management, and there are questions about how data management plans can be more effectively used, so we think that's positive. But there is reinventing the wheel at many institutions. Again, this may be pointing to maybe a regional or larger solution so that every single institution isn't trying to do this. And there's a lack of clarity or policy, including some about the responsibility of what the institution has for the research data within the institution. So some of these things need to be clarified.
Clark Gaylord, Virginia Tech, Table 1. We did not have a lively conversation at all. We had complete consensus on all of our matters at hand. So we started off actually turning the first question around and saying, well, what's different from 2011? And what are the major challenges that are different from then? And what are the things we thought were major challenges then? And one of the changes I think we saw was we have fewer researchers recognizing the why of data management, but there's still plenty of them that wonder about the how. And the need for training and awareness of the technologies and policy and governance matters are still out there, but at least the idea that I have data that are going to need some kind of management, there's at least a nebulous cloud of understanding about that. I think there's still a lot of disconnect in terms of funding models and a lot of different models out there. There's that question of what's the return on investment, and researchers saying, but you're just supposed to pay for it because you're the university and I'm important. So there is all that too, of course, but there's also the need to educate senior management in what's important about this, what are the costs that are important to the university and what are the costs that should scale with the research and be that return on investment. It's possible that we occasionally perceive some central IT intransigence. I know that doesn't happen anywhere else. One challenge that we did talk about, we kept on going back to problem one. I think that maybe also is very unique to us. In sensor acquisition, that's a big area of explosion for data. And my institute actually does a lot of that, so I contributed that, so I get to talk about it. And when you've got one order of magnitude change in data acquisition, that's an engineering problem. When you've got 3 orders of magnitude change, that's a physics problem. And the need to change the way we think about how we do data acquisition, and researchers not understanding that move compute to data problem of big data management. There's an important part there. There's a bit of a false belief that the cloud is going to solve everything, so occasionally you hear that scattered around. So having lobbed that out there, we also have that IT intransigence. So how are institutions meeting these challenges? On the one hand, these utility infrastructure providers, shall we say, can be a positive influence on changing the culture of IT and in general making things more flexible. So that tactical use of those infrastructure providers, we see that as generally a good thing, but also a lot of collaboration. We're seeing that in between the libraries and metadata. We didn't think the world was entirely doom and gloom on that respect. And that the industry were putting together communities of across cultural boundaries within our institutions. Challenges that are impacting research. Some of the technology things, if you bear with us, maybe some of our younger researchers understand GitLab better than some of our less younger researchers. It's possible. And similarly, they don't think about, whether it's on-prem, off-prem, they don't tend to think that problem as much, and there's advantages and disadvantages for that, but they do understand they have data and they have to be managed. So I think that's it.
Hi, I'm Deb Morley from Drexel University. Common themes among all the tables, so I'll just try to skip over some of those or go quickly. Top of our list for challenges was cost. We also identified meeting compliance with various regulations, and with that, really needing expertise to interpret various regulations and help provide guidelines and things like data use agreements. There's the whole question of what incentives are there for the researcher to share the data. Governance often doesn't exist or is very uneven across institutions or within a single institution. The question of how do we get to general solutions? It seems like a lot of the really interesting solutions we hear about seem to be very niche or discipline specific. And the whole area of collection management and the challenges there around record retention policies at institutions that are either not current or not enforced. Nobody is actually going forward with sort of the de-accessioning of research data, adding to the challenge of storage over time. Some ways in which institutions are addressing these challenges. Some are developing incentive structures for sharing resources, whether this is through consortiums or using outside organizations for services like outsourcing the computing aspect. The idea or the practice of actually paying for the part of the service that is not valued, meaning not valued maybe by the individual researcher, but very much valued by the institution. So the institution probably very much values having a well-run, secure service. So identifying those things and having the institution pay for those. Developing models of experts, and that includes defining specific roles for individuals who are involved in data management and data curation. There's a project called Credit, big C, big R, big T, about contributing role taxonomy, the idea that using name authority to actually identify and give credit to those who are involved in data curation. In terms of impact, it's impacting the ability to reproduce. We feel there's less thought up front about research design and the collection of the data. Researchers have concerns about credit for their research. Compliance sometimes slows down discovery or even stops it. And on sort of a very negative note, we ended with the idea that there's even a decline in society's trust in science as topics like, producing work that is unreproducible kind of spin out within our communities.
Sharon Geva, University of Michigan, Table 3. We did try and game this ahead of time to pick out the things that not everyone else would be saying, so I hope we manage. So major challenges. We talked a lot about the difference in data formats. So those of you who know atmospheric science know that that started a long time ago, and it makes it virtually impossible to port things around and to put them in standard places. But it's not atmospheric sciences anymore. They're new disciplines, and they're still their first step is to create 6 different formats, which makes it very hard to deal with. The other thing, and I will repeat what I said originally in the morning, there needs to be a statement of intent. This can't be an everyday fire drill. We have to deal with this kind of thing. What does the university think that should be provided? More importantly, what do our funding agencies think that should be provided? I mean, what is the bigger picture here? Because we, on a day-to-day basis, can't just come up with that as we go along. And then this total lack of efficiency, right? If you're buying your own stuff, that's not very efficient. You know, if each university is inventing their own thing, that's not efficient looking at it from the funding agency point of view. How are institutions addressing these challenges? So, especially in smaller institutions, we see these kind of grassroots efforts to build cyber infrastructure based on basically going around and trying to get enough faculty together to put in a proposal. Obviously, for larger institutions, probably this isn't a solution. But for smaller ones, people actually have to do it, because the flip side of not being a larger institution is you have much smaller budgets. So you actually have to put that together. You have to put together proposals to get training for students on how this is important, how it isn't important, because you don't have this huge amount of faculty. Other thing, so at Michigan we have, luckily for us, we have ISR and ICPSR, shout out to Tom. We have data librarians, which is a huge boon. A data librarian is not the same as a librarian. They work together to manage and administer data use agreements. That is invaluable. They actually know how to deal with these kind of things. We also have library people who do outreach and things like that. So that is another important thing. And the last thing, how are these challenges impacting research and discovery today? Well, one of the things is it's darn hard to explain all this stuff. I mean, how many of my technical colleagues have had faculty who think that a data management plan is to leave all their stuff on Lustre or on Scratch or on Temp, right? I mean, it's hard to explain. And the other thing is we end up, of course, with the Newegg and Best Buy way of dealing with data management. And lastly, we spend a lot of time dealing with politics and funding issues, which we could use to do better things. And they, by the way, also impact the workforce development, because students are running the Newegg stuff, and students are constantly being asked to do whatever it needs to be, because there's no money.
Hi there, Elizabeth Long from the University of Chicago. So the things I wanted to pull out that we talked about were first incentivizing working with data management, data sharing, and the challenges there. And one of the things we talked about in particular was the differences in different fields and how we could maybe do more to understand what would incentivize particular fields. Because we talked about, for instance, the fact that, there was, Victoria talked so compellingly about reproducibility, but there are some fields where that's not really much of a carrot to them. They don't see what the value of that is. We talked also about kind of the process of peer review of data and software, and how do you know what quality, whether something is of quality, and how do you give, some kind of credit for that. And so out of that, we were, in terms of some of the solutions that are starting to happen, we had someone at our table from UNC where they're actually providing data verification processes for several journals, so that everything that's getting, submitted to those journals, the data is having to go through a verification process. So thinking about how we could build some of those structures into our scholarly communication world. We also talked about career paths in the area of data management and the challenges right now where you have a lot of students not sure exactly what their future career is in academia, but this not really being talked about still within a lot of departments. We, I know, are starting to hear it from our graduate school that is aware of it, but that it's really something that we need to think more carefully about how to build into our academic training. We talked about the kind of issues around domain versus general solutions, and that, figuring out which is the right way to go with these, that sometimes the very general solutions really don't actually serve the domain, and therefore there's no incentive to use them. So we talked a lot about the need to kind of build consensus around more communal solutions and to stop funding everything that builds these, maybe openly available, but still siloed solutions. And then the last thing we really focused a lot on was definitions, and the fact that we still really are talking at cross purposes across different fields often, and that there's a real need to think about how we can, have we even defined what the this is when we talk about building a cyber infrastructure, for instance. And so they are talking we talked some about how, for instance, teaching, building this much more into our curriculum and our training for people so that it is something that we're all understanding and speaking a same language around.
Over to you, Bob. All right. So I guess major challenges, we recognize a lot of what was said. Anita de Waard, Elsevier, and we were table 5. Definitely the idea that there are many people who feel they must be involved in research data management at an institution, but not many people who feel solely responsible, and therefore the idea of the buck being passed. And also the lack of bucks with any one party to be able to implement any of it. So libraries have a huge role in curation and archiving. IT departments know a lot about handling big data and handling things like Dockerized collections and runtime environments. Their skill sets and their ways of thinking do not overlap. And they both think that they should be the ones, in charge because they're the only ones who know how to do it well. And then lastly, the researchers feel that all of this is a hassle and is a danger to their already very limited amount of time to work on their research. So we were kind of seeing the conflicts, and that's within the institution. Then you have academic societies and funding agencies and publishers and software companies and other organizations who also think they have a role. So those are some of the key challenges.
You're coming back.
Over to you, Bob. Yes.
I'm Bob Hanisch from NIST. I would say that the major challenges are not primarily technical or technological. There are many, many solutions available. Choosing the right ones, configuring the right ones is still a challenge, but the tools and technologies are largely there. The major challenges are really more cultural and social. How do we embed this whole mentality about the value of data management, data curation, metadata tagging into the mindset of the way that researchers approach problems from design of experiment through to reporting out, curation, and long-term preservation? And that is going to require sea changes that will just take a long time. One of my colleagues ends most of his presentations with this thing about science advances one retirement or funeral at a time. So we just have to be patient, but make sure we make it as easy as possible for people to do the right thing.
Right. And on that note, addressing the third bullet, we thought it was quite key to make sure that, especially for the researcher, that the tools and the processes that are proposed improve their daily lives today. We had some examples where, in using an electronic lab notebook, a researcher whose name was actually Nathan Urban, and so we call the project Urban Legend, funnily enough, but was able to find the data that his postdocs and his students had created, and those postdocs and students could find their own data, and that was lauded as the main benefit of implementing this process. Another key point was that you separate out the curation and the storage of the data from the sharing. To circumvent the issue, the fear of being scooped, it's very important that researchers understand that they are completely in charge of their data. By adding metadata and by having the proper provenance processes in place, they can find and integrate their own data without immediately having to share something that they're not ready to share. And lastly, we said in terms of education, it would be really good if students, at the moment that they're learning to do the science itself, so when they're learning to work with the equipment, when they're learning to prepare the samples or what have you, or doing the computational processes, that's the moment where storing and curating this data should be an integral part of that process. So we thought in terms of education, that could be another impact.
So I get to interpret the notes I took myself. I'm Dave Fearon from Johns Hopkins for Table 6, and I think I'll try to maybe stick to some of our examples. I think our group really focused a lot on challenges, and with some of the other points kind of sprinkled in. I think a big theme for us initially was around the legitimacy of data management services within an institution, where it should come from. So the balance between the external incentives and the internal academic support. We saw the administration really needing to support these services from the beginning, and we asked what institutions are doing it right, and Cornell came up, and we don't have anyone from Cornell at the table, but we kind of saw that as an example of starting with a collaboration that involved not just the library, but other groups, and that putting yourself forward as not just a library service, I think was good, especially at the beginning of our field. At Johns Hopkins, we sort of did the same thing, but are now coming back to, as our libraries here and elsewhere are growing in research services in general, to be able to come forward again and say, yes, we are the library, and here's all the things we can do. And also being adaptable. So for example, if an open access policy for starts up at a school, being able to jump onto it, adapt services to it, but also do so in a way that's sustainable, which is easier now that we have more plug-and-play resources in place. The challenges of a new area of work is the workforce able to keep up with these new demands. I think everyone still has one or two people, but there has been some success of having people come into these services who don't have an MLIS degree, who come from the research field, being able to build that part of the workforce. Let me see. So another theme that came up was who's really driving the initiatives. The tradition from some of the federal and government policies are to let the institutions, they give the unfunded mandates, let the schools figure them out, and we're still in that point where in some cases there still aren't discovering policies. You'll have groups like Tech Transfer being suddenly discovering that people want to share data and being horrified by it. And there's struggles within disciplines of the need, for example, the younger and the adjunct faculty wanting to keep data for competitive reasons versus sharing data is more acceptable to established groups. And I think the general solutions have been mostly around being efficient, helping people do their own work better, can spill out into a broader acceptance of open access and sharing. Okay.
All right, thank you all very much for your thoughts. If at all possible, let's try to keep those in mind as we head into this afternoon's breakout session where we can build on some of those ideas. We're going to move into our next panel now, so if the panel 2 contributors could please come up. All right, so our second panel of the day is so having addressed kind of challenges and problems that we're addressing, we're going to now move into some actual examples where we discuss some of the things that have already been implemented for research data management. The moderator for this panel is Rashana. I'm going to let her pronounce her last name. My apologies. Rashana is the Director of Product Management and Design for Globus, a research data management service from the University of Chicago and Argonne National Lab, and I'm going to let you take it from there. They should go up, yes.
Okay. Good afternoon, everyone. So my last name is Ananthakrishnan. It's pretty straightforward. So I'm delighted to be moderating this panel. She said, we're going to shift focus. We heard a lot about challenges, what our campus is doing, and this panel is more about implementations and solutions that we have out there that we can learn about, right? I was going to start the panel with a few slides, if I could get my slides up, to set some context, and then I'll turn it over to the panelists. They'll each get about 8 to 10 minutes, now that we have all four. And then we'll open it up for questions. Okay, so as we wait for that, I'll provide some context. So in my role with Globus, my primary role, I speak with a lot of users. My job is to go understand what are the gaps, what are the use cases that RCC centers, end users, researchers face, and how do we fill these gaps, right? How does the solution we develop meet the needs? That's kind of my role. And as a part of that, we see a lot of different research data management solutions, right? And I say those with air quotes because it's a wide variety. So you see things from ad hoc research data management, like Sharon pointed out, somebody going to Best Buy and stringing up a bunch of hard drives under their desktops, to campuses. We saw some Cardinal as an excellent example, but lots of other campuses providing solutions for users. So that's a wide range that you see, and the focus here is how can the software and the services provide the connections. So I'll give this one more minute if I get my slide up. You could join us. If we get the slide up.
Does it make sense to let Leslie speak and come back to you?
To share. And it's going to mess up the flow quite a bit. I just have 2 slides for preparations. But we need at least 2 slides. Yes. Any one of you want to ad-lib here without slides? I don't have slides. Do you want to go? Okay. So we're going to start with Leslie because she doesn't have slides. Let me do a quick intro here. Leslie McIntosh is the inaugural Oh, man. Okay, so I guess I get to show my slides first. 2 more minutes there, Leslie. Let's see if this works. Yes. Okay, so this is one ad hoc research data management picture. These are not photoshopped. They are real pictures from the labs, right? You can see the orange in the middle there. Anyway, so researchers, quite a creative bunch there. So those hard drives have indexes. There's an Excel file somewhere, or maybe a log notebook that tells you what is in those hard drives, and this is some solution. But more often than not, you actually see a lot of infrastructure, right? There are science DMCs. There's been a lot of effort that's gone in CC Star funding and things. Campuses have put in infrastructure to use networks, various kinds of storage, on-prem, off-prem, that you can use various tiers to be able to store those things, right? I mean, Pastor, what we need here are these services. How do you make this infrastructure available so that researchers can come in and use them for research data management, right? Yes, there are cultural issues, but then there are also technical issues, and some of those are providing these services, right? I'm not going to go into what these services can do. We all heard lots of the capabilities today, right? Being able, ultimately reproducibility, discovery as the goal for these services. So that's kind of the crux of this. What kind of implementations and services can we provide for researchers to be able to leverage all this infrastructure for their data management and lower the barriers, right? I have an example, the slide is available. I have some examples of groups that we have worked with which have addressed various parts of research data management, right? The first one, the one that you see on the left here, is an instrument facility at Argonne, and they need to manage data until they give it to the user who comes for experiments. And they've built some on the Globus platform. It's a group I work with. The other one is the Research Data Archive out of NCAR, and they really have a huge archive, multi-petabyte, and they do derived data. How do they store that? How do they manage that, keep the description up to date, and make it available to the users? And then the one in the middle is even bigger. This is the Department of Energy's Atmospheric Radiation Measurement Group. And their life cycle is even bigger, from the point of collection to transformation, keeping disaster record copies, different kinds of storage systems they need, and so on, right? So all of these are different examples who have done different data management implementations. These are from my experience, and we're going to hear from 4 panelists here who have built solutions which address slightly different facets of things, right? Okay. With that, if we could have, actually Leslie doesn't have slides, so we'll just move on. So Leslie McIntosh is the Executive Director for RDA US, and she'll be leading the grant. She recently also concluded as a Director of Center for Biomedical Informatics at the Washington University in St. Louis. So we're going to get a perspective from her on both RDA, which is more standards-based, and how she has applied that for RDMI solution in a specific space.
Thank you so much, and thanks so much for having me. And I think my biggest challenge right now is transitioning from one position to another and balancing everything. So I appreciate understanding. So we were asked 3 questions, and I'm going to go through those, and I'm going to have 2 hats on. One is in my new position as the inaugural Executive Director for the Research Data Alliance, the RDA for the US region, and the other really is from my last 10 years of experience with the Center for Biomedical Informatics at Washington University, where I had very much a hands-on experience of managing a lot of data. We had all of the electronic medical record data, the biospecimen data, the clinical data, and then we merged imaging data somewhat, and then genomic data. So we had a lot of different types of data. So I'm going to come from different perspectives of both managing that and in the new position that I'm in. So the first question that we were asked is, what is the greatest challenge that we are facing implementing solutions for research data management? And I think I just want to back up and just say, research is hard, okay? The technological advances, the increased data, the complex analytical techniques, they've all increased scientific discovery, yet they've convoluted the process of scientific work, the scientific reproducibility. It's made science harder while it's made some discoveries easier, if that contradiction makes sense. And so we face that challenge because in the educational system, in our training, we're taught about pieces of science. We're not taught about the vision of science, the processes of working through that. So when I took over as the director for the Center for Biomedical Informatics, we didn't really have any standard processes in place. And I was never taught process. I didn't even know that was a field, to be real honest. I was like, oh wow, people get degrees in that. That was exciting because I had something to go towards. But I wasn't taught that, and I don't think we are. And so I think that was for me, it was a big challenge that actually led me into my current position in the Research Data Alliance with the RDA, because I was looking for places to go for solutions. And that leads really to the next question, or one of the questions about how did I implement it, the same one, what was the solution? So what I did was there were recommendations that came out of RDA, and I got an adoption grant. I was very fortunate of that. And we implemented those recommendations within our center. So the example I'll walk through is that there are recommendations for citing data and evolving data repository. A medical EMR is very much an evolving data repository. So there are 14 recommendations, and we took those and we did a gap analysis and we looked at what do we have going on, what do we don't have. But what we didn't have to do is we didn't have to reinvent the wheel. We didn't have to then become experts in citing evolving data. We could take those recommendations and we could implement those. We could give them back to the group and say, this worked, this didn't work, and here's where we got. And the other thing that did is I could then go and talk to my biomedical community, and they could start adopting to those. So we started not only testing out a use case, but then we could scale it to others based on those recommendations. So that was one of the challenges, and then one of the solutions that I tried to implement. Another challenge, just more on running a center, is there's a lot of support for PhDs, and there's not a lot of support for the, let's put it, master level, mid-level, some PhDs that are research scientists, some very talented bachelors that are in there, that are running a system, and it's really hard to get the correct training, funding for the training, things like that. And then I'm not sure, the woman that just talked about data librarians. I brought in a data librarian, and that was probably one of the best things I could have ever done for my team. And I do agree that we need more, and we have fewer of those than what we need. So the support beyond the PhD is what I think we need. I already talked about the scientific process, and then just generally recommendations. And again, that's what led me to my new position with the RDA, is because the RDA is about identifying those problems with data, looking for solutions, coming up with recommendations and output, having them used in the community, and then that fed back into our organization so that we can improve those. Because one of the challenges that we've had is workforce. Everybody's talked about that in the brief time I got to be here before, is the challenges of the workforce. And I don't think that we can all hire the people that we need. So we have to figure out how to invest in that. And that's a challenge that we need to address. So how has my work in data management enabled scientific process? Well, I talked about that example of citing a data repository. We had this system where we had data brokers, so we had the electronic medical record that clinical researchers would want. They would ask the data broker for the data, and then they would write the queries against the repository and get them the information back. What we were able to do by implementing those recommendations is cut down the amount of time, not that the first query took, but because we started assigning things like a PI, a persistent identifier, to the queries, not just the data, but to the queries themselves, that cut down on the number of hours from about 20 to about 3 hours that it took the data broker to rerun a query. And there was just a good example. I mean, all of the talk about reproducibility, when people ask me, well, how many people are going to try to reproduce your work? I'm like, we get the same clinical researcher asking us to reproduce his or her work, a few months later all the time. We did. I'm 2 weeks on a new job. I'm still working on this. The other thing in improving the scientific process is I think we need to allow our teams time to think, regardless of the level or their status that they work. They need time to think, they need the opportunity to fail, and that gives them the opportunity to improve. I am amazed at the knowledge that I have had in team members at all levels and able to contribute to solutions. And I think we need to do that more. I also think we need to work on measuring not only success, but measuring failure. We've got to learn how to look at metrics and understand the questions that we're trying to answer so that we can have better metrics. So then the last question was, what key best practices has your organization discovered or enabled as you implement data management solutions? I think I've talked a lot about that, and so I'm just going to conclude with the fact that that's really why I moved to, or I was involved with the RDA and now had this opportunity to take a new position, is because they're dedicated to identifying the challenges, and they're doing that at an international level, and I really like that, because these solutions, these problems, they're beyond each one of us, and if we look for solutions, we're siloing those solutions just like we siloed data previously, so we need to look beyond that. Thank you.
Thank you, Leslie. I'm going to invite Tom next. Tom Murphy is the Director of Computing and Network Services. He handles the architecture, design, and planning on the software development side and has overall responsibility of the CNS and its directions.
Thank you, Roshana. I actually do have slides, but if you'd not like to see them, that's fine too. Wrong ones. Want me to talk about yours? I can talk about your presentation. You can talk about mine. How's that? That'll work out good?
It's always good to improv.
There we go. I don't dance well, so I'll warn you that first. So, as Roshana said, I work with the University of Michigan's Institute for Inter-University Consortium for Political and Social and Political Research. We are one of the oldest archives in the world for social science research and collectivity, collection of data. We've had, I think we're up to almost 5 million variables we have in our database that we can cross-reference across those type of platforms and what have you, as well as I think the number is now close to 70,000 data sets and over 100,000 citations and over 11,000 actual studies that we've now keep in our archives today. Our process is, our institute actually houses over 20 different archives. Our general archive, which is really where most of the members that sign up with ICPSR gets most of their data from, but we host several websites or archives for many of the federal agencies as well. So these are the questions we're going to, the very first question, this is just a microcosm of the things that I came up with off the top of my head when I was asked to speak in this panel. Each one of these particular items has a significant impact on the researcher. It has a significant impact on how we collect data, how we catalog data, how do we curate the data, make it reusable, searchable, and things like that. In addition, to the dissemination side of things, many of the researchers, and I was in a conversation earlier this week with the Center for Open Science and their CTO, was how do we not just make the data reproducible, or how do researchers, once get to that data, then make some decisions about the data? Online analytics. Amit and I talked during lunch about some data visualization, what he's working on, and visualization of the data actually helps quite a bit of discoverability as well. So these are just the top ones that we point out with what we've been doing in ICPSR. We have taken the stance that when I first got there about 3 years ago, the industry, specifically the archival industry, had tremendous amount of needs that we've all talked about today, but nobody's really addressing the bigger picture. They were really trying to address the bullet solutions for each one of these items. And the challenge with that is that while you may solve one item very well, you alienate the other items from being leveraged across the board. So some of what we focus on was the research data lifecycle management process, which is we at ICPSR don't focus on researchers, we focus on the outcome, the data producers from that research, and making sure that it's not just discoverable, but it's reusable data. And it makes a big difference in the curation. I always call this my archive sandwich, if you will. The 2 slices of the bread or croissant roll, whatever you prefer for your sandwich, is we have the external facing, how do we collect the data, the ingestion process of that data. And then we have the other external side of that slice, which is what are we actually going to disseminate out and get back into the hands of the folks looking for data, searching for their particular interest and what have you. And then in the meat is what we call our data curation side of how do we make that data from ingestion to reuse actually valuable. And I'm sure folks who've done curation understand that the bulk of, and I think Dave actually pointed this out in one of our discussions at the table, is there's two types of curated data, or metadata, that was, the really poor and the non-existent. And the challenge with that is getting it from those two levels up to where it's actually highly searchable, highly discoverable, cross-referenceable in multiple studies as well as even within itself. And how do we get to those points? These are some of the things that we've actually been focused on at the University of Michigan's social area. And these tools that we've developed are intended to be used outside of the data discipline of just social science because we believe, I strongly believe that social science is one science that can plug into several of the other sciences and reuse those outcomes collectively to generate new data outcomes and new long-term solutions. Dynamic metadata harvesting is something that's somewhat new. We exchange metadata across the university with other universities, with other institutions, and with several federal agencies today, specifically NSF and NIH. We collect their metadata records and make sure that they're accessible and reusable across studies. But some of the other things that actually have a metadata editor is being able to get metadata. When we curate data at the University of Michigan, we have about 10 to 11 levels of curation. And I saw a presentation not too long ago by a librarian from University of Michigan that just says, why do data curation? Is it really valuable? And if it's not, if you're not going to reuse the data, it's really irrelevant if you're not going to reuse that data. But the reality is with data curation comes, we need information from that researcher that typically isn't gathered during a deposit session. We've built some things in now with our newer technologies that actually scrape a lot of that information and can put some information out there for the researcher to kind of say yes or no. Yeah, that's what we're doing. Or, yeah, we've got some challenges with our SPSS file that we have some null or missing values, and we can help give some of that information and curate that data even before it becomes ready for publication. One of our biggest challenges is long-term sustainability. I've heard it talked about throughout the day so far is getting the funding agencies or just the researchers to be able to have a place where we can store data, archive it, but also keep it so it's sustainable. We have over 50 years of research data that we house today and continue to house at the University of Michigan. That has to go on forever because the data is extremely valuable. But on the other hand, there's a cost associated with that. How do we mitigate that? Through cooperation and collaboration with other institutions and industries. Quite a few of the collaborative and iterative data and study publishing is being able to leverage our data sets, as I mentioned, from our discipline across many of the other data disciplines, and how do we get that to the point where we can start attracting other data sets, not just in the social and political science realm. I'm not sure how well you can see this, but this is the research data lifecycle that we follow for the most part at the University of Michigan. And the upper part is where the funding kind of starts. The research idea is funded, accepted and funded. It moves along to the right. There's some active data management tools such as SEED, which I had the opportunity to work with Jim on with NSF funding, and also OSF, which is the Open Science Framework from Center for Open Science. Dataverse does some of this type of work as well in their tools. And then once they've gotten it to that level, as that kind of manages the infrastructure for the researcher side, but once we take it to the next level, which is how do we propagate this data and make it available? How do we publish it? How do we get it exposed to the rest of the world in a timely manner so that the scooping doesn't happen and things like that? A lot of the technology tools are in place today that protect that. And then we take it around to that next circle. You'll see the red circle from ICPSR. We handle most of the bottom to the upper, going back up to the top today in our world, but the information that happens on the inside there, how we get the metadata management, collecting the metadata, getting certain searchability and reuse of that, the data repository as well, those are all things that we focus on with our application and architecture we've put into place. We leave the active data management to those folks that are best suited for that, and that's, again, the seeds of the world, the OSF, and giving that infrastructure, keeping the technology out of the researcher's responsibility and making sure that it's better used, that they better use their time for actual research. Primary drivers, these are the focus areas we have on the researchers, the publishers, because people look at publishing, we do journal and institutional repositories as well. Making sure we can ingest any type of data across any type of discipline. How we curate that data is dependent upon the type of skill sets and personnel we have available for that. And then just enhancing that data so that it can be found, discovered, used in cross-tabular analysis. And then our technology today is all based on open source technologies. And actually I've had discussions earlier this week about being able to take what we've built and make it more open source available for the rest of the community, as there's some tremendous amount of opportunity. And just a real quick idea here, these are the guiding principles that we follow for our development processes. These are things we said that we follow these principles, we can do the software we want to do for the industry we have. But we went from ideation of a data archive to be able to collect any data with the administration change, making sure the data that want to be pulled down off of certain sites or certain federal sites had a place to go. We created that, had the idea to create that, and up and running in less than 9 calendar days. So that's what this type of repository software can do and how we're addressing the data management side of things. So thank you for your time.
Thanks, Tom. Next up is Jim Myers. Jim Myers is an associate research scientist with the University of Michigan's Institute for Social Research. He's also a co-PI on the SEED data project, and he's going to tell us more about the National Data Service.
So the reason I get to talk about the National Data Service is I'm on the Technical Advisory Board for NDS. I used to be at NCSA. And so I'm subbing for Christine Kirkpatrick, who's the executive director there. Before I go and tell you my opinion of what NDS is, I'll point out that Bob Hanish and Anita DeWard are on the executive committee there, so they can correct or tell you the more official version as we go. So just to give you a sense of what NDS is, it's a consortium that is bringing together people, infrastructure, that were basically the same thing that we're talking about in this room. People getting together to coordinate as a set of stakeholders across technologies, libraries, domain scientists, and so on. And the real impetus is that we've all seen this vision that you can get on your computer and talk to it, and it will find you data and plug it right into your analysis tool, and then you'll be publishing new data that afternoon. And realizing that a lot of the reason we're not there is because we're all individual projects and nobody is doing all of it. So that's really what this group is about. There's things in there about large-scale data interoperability, looking at cloud solutions to be able to plug things together, new technologies to fill in some of the gaps between projects that are going on, and basically a place where a lot of the projects that NSF funds that are working on this stuff can get sandboxes, coordination capabilities, and so on. So again, I'm partly doing short shrift to this just to stay within my 8 or 9 minutes, and if I can figure out how to make my slide go forward. All right, there we go. I'm just backwards. Here's the list of who's in NDS, and again, I'll put that up there just long enough for you to see there's lots of names and not really go much farther, but the slides are out there. And you can see, there are different categories. There are developers and providers of resources, universities, libraries, publishers, different domain communities, and so on. Oh, all right, and let me get back to this. And then this is a slide that looks like it has some animation in it, but came from Kenton McHenry to try and explain, where we think we are. And again, the point is, don't look for any of the names in there. Just think about the analogy to the internet, that at one point, we had sort of walled gardens, and then you get HTML, and then suddenly you expect everything to work together. We've got applications that do analysis. We've got places that data can be put. We've got technologies and storage resources. And right now, if you want to use analysis tool X, your data better be in repository Y, and you better be on hardware Z, because that's all we've gotten to right now. And really, the users want, I can use this tool on anything because we've got some interoperability. So that's where NDS is trying to go. Oh, there's more names, all right. So that's I guess, the better picture. So to get over to the greatest challenges, I think all of the things that Tom was mentioning that are sort of on the technology side are out there, and I, like everyone else here, will be able to do a better job at this next year than we can today, right? So these are unending challenges that we're going to get better and better. But really, what I talked with Christine about here is that our biggest challenge is really getting the shift to the infrastructure perspective. It's not project by project. As long as we keep doing that, we can't serve the user's needs. And we really need to think about how, projects and prototypes keep moving us forward, but when you make that step forward, how do we disseminate that back? How do we make that new thing interoperable with the old? How do we just get, for the people who'd like to publish their data today, how do we provision? So we really sort of push this in it's the socioeconomic issue rather than a technical issue. And again, I work with cyber infrastructure researchers. I am one to some extent. There are always things we're going to do better next year, but the reality is that we're good enough already for the 80-90% of the users, and we need to just get moving. And the reasons we're not, they're socioeconomic, and I helped put the name, urban legend in here earlier this morning in the other session. But the point is really that, when you talk about costs, there's always somebody who's got petabytes of data, and thinking about how to store that much data for a long time is a big issue. But how many of your researchers have a graduate student lifetime that has, less than a terabyte of data, which we're looking at, tens, not hundreds of dollars for some of this stuff. That's the coffee budget for that graduate student. Why can't we solve that problem for those people now? In some sense, we're worried about the fact that this could be a huge mortgage in the future for some of the big data that's coming, is sort of letting us ignore the fact that a lot of this stuff just could be put to the side, and then we can concentrate our resources on, how do we deal with the harder issues. Same thing, researchers won't publish. Well, they don't want to publish when you sort of come to their door at the end of the project when they can't get any value out. But what you're hearing here, and what we did on the seed project that I'll say, just tiny bits more about later, is that when you make it so that researchers put their data in and it gets enough metadata, they can find it and bring it back, and their grad students can actually point at the right data for their professor, they want to do it. If they get a persistent identifier out so they can cite it in their paper, and you didn't make them do a whole long set of forms otherwise, they want to do it. So really, pushing for your data must be completely machine readable so an AI of the future can get to it is what they won't do, right? Because that AI doesn't exist right now. The tools that could take advantage of the metadata we're trying to get them to put in don't exist. So again, there's sort of an urban legend between those things. And you can kind of go on down with the formal metadata. Reuse won't happen when it costs so little to store the raw data. If, it's heretical, but if 1 out of 10 data sets gets reused and saves somebody $10,000, you've just paid for the other 9, right? So, or if after 5 years you drop the 9 that haven't been done, you've gotten rid of the 100-year mortgage on most of the data. So, if we think about some of these practical aspects, we could get started. And again, if you go look at the white paper I put in, we could have a data census. We could actually figure out what's out there if we had this stuff in place. Right now, we don't even know. If we found out what the real problems were with that data, we could focus our research better and we could do better things. So let's get started. How has this impacted scientific progress? Well, NDS is a consortium, so each of us has our individual successes. I think in aggregate, they're tremendous. Just on seed, we've managed to publish 4+ terabytes of data from multiple groups. It's all sort of self-service technology. I'd love to spend a half hour telling you all the wonderful things about it, but these are people publishing their data, getting citations out of it. It's grad students archiving their work so that they can work with a theorist, a modeler on the other side from an experimental side. There are things where we've rescued data on, forest canopy growth that was going to disappear elsewhere. So, I can say that and then multiply that by, all the names you saw on the other slide. We're impacting things already. The other thing on this slide is, the National Data Service, as a consortium that's working on technologies, also has, with the cloud hosting, they've been able to basically put up a lot of the different kinds of technologies for repositories and tools so that you can fire them up, on demand. That's been being used in classes now, so you can have 50 copies of, CCAN and Dataverse and go play with them and see how they work. That's getting tied into computation over data with things that they're sort of side projects, as well as a thing called data DNS in astronomy, but the idea is basically, you can use those same kind of cloud technologies to pop up 50 analysis environments running over streaming data in. TerraRef is actually an agriculture project where they've got instrumented fields, multiple terabytes of data streaming in, and that can now be used in a class because you can pop up the analysis environment right over the top of the data. So NDS as a consortium is showing how some of these things start to come together and start thinking about how could you do that for data in any repository, basically pop up 50 analysis environments over the top and keep on going. Okay, last slide. Other than acknowledgements, what are key best practices? Well, I think, NDS is showing, like RDA and so on, when you bring people, and like this conference here, when you bring multiple stakeholders together, you get the right answers out, and you really need to get everybody's perspective, everybody's expertise together. And I think, the real lesson in there is that as an ecosystem, we're more valuable than any individual player, right? Together, we actually make the pie bigger. We provide more value to researchers, and so we don't have to care about who's going to get paid for doing what if we're going to make things, 10 times bigger, because we basically are going to start having a bigger science impact. One of the things that again is in the position paper this morning is NDS. We have a universally accessible data publications pilot. It's basically just trying to get to what if from every system you could export the data and the metadata. So if I go to a DOI and no matter what system it's in, I can at least find out what files are in it and what's the metadata. If I stop even before, well, what vocabularies do I use or what file formats do I use? Put that off as a second problem. If we just got that far, that allows people to basically start pulling data into different systems. It allows you to start doing a data inventory across the country. So, and then there's an RDA group that's trying to get the next level down of some of the, what are good minimal metadata vocabularies and so on to try and require within that kind of thing. So, those sorts of things I think are possible today. The other kinds of lessons out of there that we're really talking about socio-technical solutions here. And again, the kind of, there are lots of these, but the three examples here are, persistent identifiers are not just you should do this, it's a good thing. Persistent identifiers are the thing that lets you start talking about citation and credit. I can put the PID for the data in the paper, and then people go refer to it, and they download the data, right? So it sort of, that technical solution drives good practice, right? It allows good practice. Same thing we've seen on both the SEED project and an NDS, this idea of service and hosting helps to solve some of the problems of ownership. In SEED, when we said you can put your data in SEED and then we'll have the SEED data repository, everybody said thanks, bye. When we said in SEED, you go create a project space, you brand it, you put the links to your home project page in there and it shows you your list of data, they said, cool, you can host that, I don't have to get the hassle and yet I keep the branding. I think all the way down, every place you look in this, if you can have the development projects that build cool software, get some credit because they've got a little powered by tagline on the bottom, and yet it's hosted by Amazon or by supercomputer centers, whoever is going to do the hosting, you can start playing. The technology helps you solve the social problem of letting everybody have some ownership. And again, we've heard over and over today this idea that the value is in having data be part of the life cycle of doing research. I've done some short 5-minute presentations sort of blaming paper for having gotten us to this place where the paper's in the notebook in the lab and you have to give it to the library at the end, and it's not yours anymore, it's theirs, and it's only one place. Data's not like that. It can be in the lab and the library and in an analysis environment, and as soon as you start breaking that, you can really start to see that together we can drive a lot more value than individually, and that's really that added value sort of gets you over all the hurdles of how you're going to pay for this stuff. It's like it's going to be 10 times more valuable when we do this, so let's keep going. All right, thank you. There's a link and names.
Thanks, Jim. So our last speaker is Dave Collard. He's a technical officer for the Digital Preservation Network and is responsible for coordinating operational aspects of DPN infrastructure.
Well, while we wait for the slides to go up, I just want to say that I appreciate being the wrap-up speaker on the post-lunch doldrums. And I'll try to keep this light and quick and just talk about a slightly different view of our three core questions that were presented. And I'll start with a brief description of DEEPN and our membership community. and then frame the presentation around a nascent experiment with peer-to-peer preservation. So my title is technical officer, but honestly, most of my time and effort is an evangelist for the long-term preservation efforts and a coach for interinstitutional projects. So DEEPN is a membership organization. We have about 50 members spread across the U.S. Our services and agreements are a commitment to ensure that assets remain available for restoration by the Academy. And the service is a broad preservation infrastructure. And we emerged from the library and archives community. And you could go out to our website. There's a lot of information about how we were constituted and why we're here. One of the big issues here is sustainability. And sustainability and community involvement in data management standards and practices are a key challenge. And that starts with a commitment to cooperation between institutions for employing and using standards. DEEPN is an investment by the community in long-term preservation. So our strength and our weakness is the community itself. That investment includes preservation curricula, workflows, metadata standards, and peer advocacy. And the purpose is to protect all deposited assets against being trapped by a single point of failure. And that may be institutional failure, geographic issues, political issues, really looking at stewarding assets through organizations that aren't directly involved with their production and ingest. So having a little bit of separation space, that air gap in between the actual producers of the content and the long-term preservation of that content. Our question was, how has your work in data management enabled scientific progress? And I kind of grade out the scientific progress since we're really a community organization. And our core service is data authenticity and survivability. By that, we support independent archives, independent implementations, and our service nodes follow security best practices. So we're a group of providers focused on content and preservation in dark storage. And we support data provenance in all of our services, so we feel it's really important not only to preserve the content itself, but really that evidentiary chain of custody of the data to make sure that if it is recovered in the future by an institution or another researcher trying to reuse it, that there is proof of authenticity of that data. And that seems to be especially important in the current economic and political environment. So what key best practices has our organization discovered or enabled? Well, we really feel that community-driven preservation and access to research data is the answer to that. I think I might have jumped one slide ahead. Let me go back. So yeah, community-driven long-term preservation. To illustrate, I'll quickly tell you a story. In the fall of 2015, a group of 11 DEEPN members formed a heavy users committee to really take a look at long-term storage of large amounts of data. And 11 members out of our total of 50 members is about 20%, so that's a pretty sizable group of our membership. So they met for about a year and a half, and after a great deal of effort and compromise, they came up with a set of recommendations. And those recommendations identified important components of cultivating the use of preservation services by the members with large-scale data needs. This was to engage heavy use institutions and help DEEPN explore concepts to build the next evolution of our services. We wanted to exchange content as recommended, if we wanted to do that, what policies and agreements and technology needed to be in place and what services and advantages should emerge from the proposal. So we set to model this. The recommendations really expose changes that some members are experiencing in their local environment. When DEEPN was first initiated back in 2012, the member consensus leaned toward there being a gold standard for a preservation supplier, and that was going to be DEEPN at the core. The cloud wasn't really a significant factor at that point, and many institutions didn't have campus-wide support for large-scale archival storage. And for the majority of our members, this continues to be the preferred model. We have a lot of smaller institutions that just don't have the resources that many of you do. But institution-centric models are critical to preservation success. Central IT, research computing, libraries, and archives tend to be siloed implementations, as we've been talking about today, each with interesting political and funding models on your campuses. It's recognized that campus resources are essential for institutional strategies. Research content workflows, especially high-performance computing and data locality, those are all important issues that you're grappling with. Integration with institutional repositories and open access publishing platforms are also considerations in this model. In those cases, DEEPN can still be an integral part of that institution's overall preservation strategy, but perhaps not that gold standard or core. So that's how we arrived at this experiment in peer-to-peer preservation. So to review very quickly, the original DEEPN model provides a high level of preservation to the member organizations. However, it doesn't provide flexibility in the case of organizations where DEEPN's just part of that broad preservation model. Our base service is a 3-copy strategy, and that may be overkill for some of our members. We try to simplify the legal processes for peer-to-peer storage and really establish support for transactional models. So trying to go quickly here, there are several areas of distinct work. The policy area, which I think is the most challenging. How are contributions and allocations of storage tracked? What are the service models? How are costs and efforts modeled and compensated? And how do the activities map into the current DEEPN transactional model? There are legal challenges. What should be included in peer-to-peer deposit agreements, terms of services, and DEEPN's role? Membership and finance, since this impacts the DEEPN membership. There are a lot of changes that need to be looked at there. And lastly, technical issues. What tools are we using to move the content? How is the work scheduled, executed, and verified? And what level of effort is needed to support operations? And who's doing that actual work? So we have some pure scenarios here, and in the interest of time, I'm going to just gloss over these very quickly. We've been looking at one-to-one, but one-to-many and many-to-many models for exchanging these, doing these peer exchanges. A lot of that depends on the needs of the institution. And what we're looking at is the simplest model first and iterating towards more complex models. And I'd be glad to take a look at some of these issues with any of you individually afterwards, but once again, in the interest of moving forward, we'll jump over that one. What we're really looking here with DEEPN as a community provider is a value chain. The DEEPN model assumes that there are wide varieties of skills that match with needs within our federation. And it's a community approach sustained by mutual benefit. This value chain is an interactive system with the flow of services highly dependent upon relationships throughout the system. The approach takes a whole-of-chain perspective and emphasizing the importance of collaboration. It highlights how effective partners align their skills, resources, and behavior to deliver higher value services, and with the returns being equitably shared to sustain partners' involvement. So we really are about that core community, and I know several of you are members of DEEPN now. So we're trying to rethink digital preservation. I put up this sign here on the right that safety is the presence of positives, not the absence of negatives. And I've been in the UK for the last week, and this was up at a lot of construction sites. And I thought that's a really good framing of this. What we're really looking for is a group of positives in this community. How do we move this forward? We all know that preservation is a game of probabilities. We're trying to minimize risk, and that activities are undertaken to reduce the likelihood that a given object would be lost or corrupted. But just as in the physical realm, there's no 100% guarantee that all things will survive. So it's important to realize that digital preservation isn't a single act by a single institution. It's a series of activities over time by a community. In support of that, we have a joint preservation code of ethics along with other providers. We believe that preservation should be sustainable, affordable, and easier to use. We serve the scholarship community. We're collaborators in the endeavor with a sustained commitment to the cultural and academic record for the long term. And we're committed to the survival of the academic record, even if one or more of our organizations fail. And we feel that that's a big part of this community. So that's it. Thank you very much, and I'll be glad to talk with you more about this or answer your questions.
Thank you, David. So we have time for a couple of questions here for the panelists.
I'm at Chalacia, San Diego Supercomputer Center. I just wanted to make an observation and not necessarily burden the panelists with this question or comment, which is, I think a lot of the discussion which I saw at the breakout session and the presentations now and in the morning are kind of focusing on what I think is the tail end of the problem, is kind of sharing or publishing the data when things are done, not necessarily at the head, and how to make researchers' life easy and have all those things kind of go on from the get-go. I think Anita alluded to it, Jim alluded to it, how those tools and software infrastructure can make researchers' life easy and have them get started with this whole process early on, while at the same time make things very easy for them. When the project ends and their interest starts to wane, it's easier for them to kind of hand over their stuff to somebody else. I think a lot of us are developing technologies and things like that which are there, are kind of talking from the tail side of things, and that is a huge burden to kind of undertake for the people who have kind of little interest by the time the game is done, right?
Right. So anybody on the panel want to comment on sort of data lifecycle and tools throughout it?
Sorry.
Well, that's okay. I think that speaks to the concept that we have to move into the process, into the pipeline, to looking for solutions into the pipeline to remove that burden of responsibility from the researcher. And I think some of the challenges that have been mentioned are also applied to that. I mean, getting funding for infrastructure development is actually quite challenging, but I fully agree that that's where we need to go, so that, as I believe you were saying, you need to, you need to give the researchers something with a PID, and they're not going to have any clue what it is, but can appreciate it later. And that's building it into the pipeline, and they don't even know that everything else exists.
Yeah, and I would add to what Leslie's saying as well, that the PID is critical, as Jim pointed out, to the identification, is getting credit over there. The challenge from the back end side, the tail end side, as Amit, you mentioned, is we're trying to capture whatever we can to make sure we retain it, but if we can push that up into the researcher world without them knowing it, because frankly they don't need to understand why or how it's done, they just need to be able to make sure it is done. That is a challenge that we need to better define the problem so we can better define the solution.
If I could just add to that, data management needs to be part of the research process from the beginning. we always joke that data archaeology and metadata reconstruction is terribly fraught and expensive. And so the sooner we can get involved and change the culture a little bit of the research endeavor to make sure that good data management practices are taken on early in the process and continue through the end of the process.
I guess I'll chime in as well, just to amplify that, during the SEED project, example after example of this sort of thing, right? I mean, the driver for some people to use some of the technologies in SEED is when they basically put it on instruments and it was streaming from the lab out, right? Now they have it in their office and their lab, and they have it across campus, right? The fact that it was in something that could then publish at the end didn't matter. It already paid for itself, right? And you see so much of this kind of rework too. We used to get, early on we get data where you'd put the data in and then there'd be this spreadsheet. Well, guess what's in the spreadsheet? File name, parameter 1, parameter 2, parameter 3. They put metadata in the spreadsheet because there was no place to put metadata on. And so again, in the normal process, we asked them to do that rework at the end as opposed to saying, if you put your metadata in, we'll auto-generate the spreadsheets for you. And so, mostly all I can say is yes, and I think, again, we can give lots of evidence and examples that this is where the value add happens.
Any other questions?
I just want to make a comment, and I think that David hit the big lotto in here. We always think about data management per project, and it should be data management per research group. In fact, that should be part of the starting package from the faculty members. If they know that they are going to be producing a lot of data, they should include that in their package, so we don't have to talk about funding, because they already have some money to deal with that. If they get money from funding agencies, fine, but if not, they have some other money.
Any comments from you guys? Leslie, David, do you want to talk about how IPCSR plays a role there? Sorry.
I've been called a lot worse. Not that David's worse, but I think you're right. In order to, I think there's a responsibility at all ends, and I think that part of it's just an educational process on the research side, but it's also a steep educational learning curve on the data management side, because many times we're not coming from the research side, we're coming from the technology. I think Jim said it best, when good enough is already here, but picking the right tools, using the right tools, that's sometimes a bit challenging. And in my meetings earlier this week with Center for Open Science, we talked exactly about how do we bring this stuff back to the researcher as they're building their data sets, as they're creating their questions, and as they're doing some of these other data extractions and data collections. The better we can get at doing that for them, the better that bridges that educational side for them as well.
Thank you. So we're out of time here, so we conclude the panel. Please join me in thanking the panelists.